The moment of inertia of a circular ring. It is a circular ring of radius r and mass m about diameter. Circular ring about diameter half mr square. About this diameter half mr square. About this axis mr square. Direct question. A door 1.6 meter wide requires a force of 1 Newton. 1.6, 1 Newton. 1.6, 1 Newton. To be applied at the free end to open or close it. The force that is required at a 0.4 meter. 0.4 meter force required. So F equal to 4 Newton. Which is this equation? Torque. When force is applied, there is rotation. There is rotation means due to torque, there is rotation. So due to force and perpendicular distance. If this is the door and these are the hinges. First case, force is applied here. F. This distance is 1.6 meter. 1.6 into F. 1.6 into F. F is 1 Newton. Second case, this is the force and this distance is 0.4 meter. 0.4 into F. 0.4 into F. Therefore, F equal to 4 Newton. The moment of inertia of a circular disc of radius mass about an axis passing through center of mass but perpendicular to plane of the disc is 2 kg meter square. So this is the disc, this is the axis. Moment of inertia of the disc along the diameter is 1/4 mr square. About this axis 1/4 mr square. About this axis perpendicular to the plane, sum of these two is half m r square. That's the moment of inertia. Now about this axis, this distance is radius, isn't it? Radius. About an axis parallel to the given axis. So about an axis parallel to the axis passing through the center of mass. So IC plus m r square is the moment of inertia. Parallel axis theorem. Now moment of inertia about the center of mass is given 2 kg meter square plus mass of the disc is 1 kg, distance is r square, 2 square. It is 6 unit. 6 unit. So moment of inertia about an axis passing through center of mass. It is mentioned. If it is not mentioned, then also you can solve using these two. Using these two. Okay. So it is 2 plus 1 m. It is 2 plus mass times distance square. It is equal to 6. A solid sphere of mass m rolls down an inclined plane without slipping, starting from rest from the top of an inclined plane. The linear speed of the sphere at the bottom of the inclined plane is v. The kinetic energy of the sphere at the bottom is. This is the inclined plane. This is this sphere. It is rolling down. It is not sliding, rolling down. This angle is theta. So when this comes here, it will have two kinetic energies. The kinetic energy, two kinetic energies, rotational kinetic energy and linear kinetic energy, half mv square plus half I omega square. In place of mass, moment of inertia, velocity, angular velocity. Done. Now, moment of inertia of this sphere it is solid sphere. Where is that? Solid sphere. Moment of inertia of solid sphere is 2 by 5 m r square. So I is 2 by 5 m r square into omega square. V equal to r omega. Therefore, omega equal to V by r. Linear velocity, angular velocity. Therefore, V square by r square. R square get cancels. 2 get cancels. It is mv square, mv square common factor, half plus 1 by 5. 5 to 10, denominator 10, it is here, 7 by 10. So when kinetic energy is asked, kinetic energy of a rolling body is asked, make sure that you consider both linear kinetic energy and rotational kinetic energy. Rotational kinetic energy half I omega square. Linear kinetic energy half ma square. Okay. In few problems, they will mention rotational kinetic energy. That time consider half I omega square only. What's the kinetic energy? Linear kinetic energy half ma square. Even that option is given. Okay. Force acts on a particle whose position vector is this. What is the torque about the origin? Torque. Torque equal to R cross F. Cross product of R and F gives torque. Cross product means I, J, K, R, 1 minus 2, 1. 1 minus 2, 1. F is 5 2 minus 5. 5 2 minus 5. Determinant. You know how to solve. Solve and get the answer. So it is 8I. 8I. Fine. Second, don't solve. Go for the third. K. K times 2 minus 10 plus 10. So it is 12 plus 12K. Plus 12K is here. Hope you understood why I did not consider J cap, because J cap all the values are same with plus or minus. So just find out for K, coefficient of K. Torque equal to R cross F. Linear motion force, angular motion torque. Similarly, angular momentum is R cross P. Momentum, linear momentum, angular momentum, force, torque.